Hi, today let's see what are virtual machines, how they are made up of, and a brief note on hypervisors. And we are also going to see the benefits of VM and also how VMs different from traditional systems with virtual machines. And we are going to see virtual machine scale sets also. Let's get into the topic. Uh, let's spend a couple of minutes on going back to the basics. Traditional computers or servers has its own CPU, processor, memory, and input I/O. Over and above, we have operating system. Either it can be Linux or Windows or anything on your interest. And over and above, we have our applications, which runs on by consuming the required RAM, memory, and hard disk space. Multiple applications sharing the same operating system and server hardware. That's a traditional way of working. Now, let's see on the virtualized environment. Here, uh, let's start with what is virtualization. So, it allows to use a physical machine to the fullest capacity by distributing its capabilities among many users or environment. Virtualization is the act of creating virtual version of the physical resources. This can be an entire computer as well as a storage and a networking component. If you look here, we have one large physical hardware comprising of large RAM physical memory, and we are going to share this large physical hardware and make to multiple number of virtualized machine using a special software called hypervisor. This will ensure that larger hardware is either equally or appropriately divided it into as many number of virtual hardware and available for us to install and configure operating systems. The main purpose of the VM is to operate multiple operating systems at the same time from the same piece of hardware. Without virtualization, operating multiple systems like multiple operating systems like Windows and Linux would require two separate physical units. So that makes a physical server and the virtualized environment are the two different pieces, and these are the concepts behind the virtualized environment. Now, let's see more on the virtualization. If you see on the left hand side, we have one large server hardware environment where we have an OS and the underlying software. Over and above, we have applications are all installed. Couple of things you need to note here. Apps might clash sometimes while sharing the resources like operating system, RAM, or physical memory. And the second thing is you cannot have multiple OS running on the same hardware base. That is, you cannot have Windows, Linux together running on the same server hardware environment. If you see on the right hand side, we have created multiple virtualized environment using hypervisor software. Contrary, which is contrary to traditional server environment. Here, you have multiple apps running in multiple OS, and also note important things. Okay, look here. This may be one operating system. This might be one another operating system, and this may be a different operating system, which will differ from the host machine operating systems. So, contrary to that, here apps won't clash with each other for resources. You can have multiple number of OS that can be installed on the same hardware base. And so you need to note you can have multiple number of operating system at the same time from the same piece of the underlying hardware. You have an operating system here, and this will differ from the operating system which are here in each and every virtual machines. Now, before the virtual machines, We have to purchase a new server for thousands of dollars and then host the server in a data center for hundreds of dollars a month. This process could take weeks or even months to set up the new server, and this process also involves to get codes, workflow approval, and a long purchase cycle process. So, with the advent of virtual machines, we use one large server hardware and design a virtual machines of our choice within few hours of work. After the cloud introduction, the same thing can be achieved within minutes. Let's see how this is possible. Before that, we need to get into know about what is the hypervisor. So I mentioned about this term hypervisor in the preceding slide. So hypervisor is used to create process on computer that behaves like an another computer. Okay, you have a physical hardware here, and I'm going to use the hypervisor to prepare another kind of computer here as virtual machine. So the hypervisor treats the computer resources within here in the physical machine, that CPU, memory, and storage, as a pool of resources that can quickly and easily be allocated to new or existing virtual machines. These hypervisors allows us to run multiple VMs on the same computer to maximize the utilization of the physical hardware. So this is very brief information about hypervisor. Now, the physical machine that the hypervisor installed, that's called as the host computer, and the one uh, the virtual machine that use the host machine resources can be known as a guest computer or simply guest. Also note down three important points that are shown on the right hand side. Hypervisor is used to create a process on a computer that behaves like an another computer. So physical resources will be treated as a pool of resources and are shared by many virtual machines. It allows the hypervisor allows to run multiple VMs on the same single server hardware. So these are the couple of points that you should have to note it down while we are talking about hypervisor. Now, as we have seen in the previous slide, the central component of a VM is a type of software called as hypervisor. These hypervisor will simulate the hardware components of traditional operating systems. Virtualized version of hardware resources like CPU, IO, memory, and others will be available in your hypervisor. If you look here in this slide, these are some of the popular hypervisors available in the market, which include Zen, Linux KVM, Microsoft Hyper-V, VMware, and VirtualBox. And this one and Microsoft Hyper-V are the much popular type of hypervisors which are available in the market. Now, let's see some more key points related to VMs. We have seen a physical server or physical server hardware is shared between a number of virtual machines. So this virtual machine is made up of a physical resources like CPU, RAM, storage. Over and above the hypervisor sits, it ensures that the number of VMs are all created. And here, this we are calling it as a guest OS, or where we have the OS installed on every virtual machine, that's called guest OS. And we have another OS running here that's called host VS. So these VMs are nothing but file or images which behaves like an actual computer. Actually, you can take a copy of this and then put it there somewhere else, and you can make a copy of that OS along with the application can keep on running. So here these VMs might use the same US as that of the host OS, or it may be different. Since these VMs share all these resources like CPU, memory, network, disk that are installed that are available in the physical resources. This should have to be a very large piece of hardware so that you can have as many number of VMs hosted on this large piece of physical server or machine. Now let's see the differences between physical server environment with virtualized environment. Before that, some important points related to VMs. So you can have 20 VMs per region as of the current documentation available in Microsoft, but you can always refer back to that one. It might keep on changing based upon how the cloud environment that it grows. You can have number of VMs that can be adjusted beyond 20 by raising a support ticket with Microsoft. Here, the VM support only 64-bit OS. That is, the host OS should have to be 64-bit format, and also the guest OS should have to be in 64-bit format. And as I mentioned, you can create as many number of VMs by raising the support ticket, and it will be charged against your monthly bills. VM shall be booted without disturbing the other VMs and also the host computer. So these are some of the additional point you have to note it down while we are talking about virtual machines. Next let's see some of the differences between physical server and a virtualized environment. The first thing is physical servers requires large, very large in fact, CapEx requirements to purchase, configure and deploy it. Whereas to to configure and deploy VMs, you need much lesser investment from your side as compared to physical server. So that's the first thing. Second one, there is no need for additional software licensing which is required for the physical server environment other than the server software like the operating system and other stuff. Whereas in virtualized environment, you need to purchase a hypervisor exclusively, and that makes a second difference. Third difference, physical servers require good amount of space to place them in the racks. However, uh, however, in the virtualized environment, there is no additional spaces required because it picks up the physical server and start using it, and so it saves space for you. Next come no on-demand scalability for physical server environment. Whatever the capacity you have, that will be retained as it is. If you want to scale up and down, it is merely not possible. You have to live with the hardware whatever you have. Whereas in virtualized environment, you can achieve on-demand scalability. So that makes a fourth difference. And the fifth difference is hardware upgrades in physical environment is not an easy task. It requires considerable amount of downtime. Whereas in virtualized environment, hardware upgrades are easier to implement. The current workload can be migrated to a backup site for repair or repair period to minimize their downtime. You can easily do the host server upgrade by doing migrating it into a backup site. The next difference is it is difficult to move or take a copy of the physical environment, whereas in the virtualized environment, you can take a copy and move around the images. And the another difference is it in physical server environment, it doesn't require any overhead layer. However, in the in the virtualized environment, which require an overhead layer that is in the form of hypervisor, which require additional attention, configuration, as well as the management. And the final difference is between the physical and virtualized environment is that it's a quite suitable for organization running services and operations in smaller scale, which are highly protective computing hardware for their implementation. Again, it may be suitable for a service and a small set of users. Whereas if you are going for large number of services with a massive user base and operation, it is better to go for virtualized environment that supports for high availability and scalability. And so virtualized environment is quite it's a good choice for large number of services and a large set of user base. So this is the difference between physical server environment and virtualized environment. Now, now let's see what are the two common types of virtual machines. The first one is called custom virtual machines. That is, you have a virtual machine. Might have its own operating system, whereupon you have file system, services, ports over and above your application sits, and put together all this one forms an image. And this image can be hosted in a cloud using Azure Virtual Machine Service. And so you can build a custom image of your choice. You can specify the virtual machine size, what is the RAM, physical memory, and other stuff. Thereby, you can build a custom virtual machine and make use of Azure Virtual Machine Service to host it in the cloud environment. So that's the one form. The other one is Microsoft has its own marketplace from where you can choose the templates that provide a pre-built virtual machines of various varieties of operating system like Windows, Ubuntu, SAP. And you can use the same Azure Virtual Machine Service to host it into the cloud. Thereby, there are two different types or general types of virtual machine that's called custom virtual machines and the marketplace virtual machines available along with Microsoft Azure. Let us see the other types of virtual machines available in the market. The first one is about general purpose VMs. These general purpose VM sizes provide balanced CPU to memory ratio. It's ideal for testing and development, and also it is a good one for small to medium databases and low to medium traffic web servers, whereupon you can use those virtual machines. Some example use cases include development and test servers, low traffic web servers, small to medium databases, building proof of concept, and then keeping the code repositories where you can use the VMs, the general purpose VM. The second one is compute optimizer VMs, which are usually built on architecture that utilizes features like non-uniform memory access for optimal, reliable, uniform performance. They require memory at the peak when they perform resource intensive work such as batch jobs on specific period. And in some cases, the traffic is expected to shoot up where you can go for compute intensive VMs. The third one is a memory optimizer VM, which is which offer high memory to CPU ratio. That is great for relational database servers, and also they are good for medium to large caches and in-memory analytics. It's ideal for extremely large databases or other applications that benefit from high CPU, vCPU counts and large amounts of memory. The fourth one is for storage optimized virtual machines, which offer high disk throughput and I/O, and are ideal for big data analysis, SQL, NoSQL databases, and can be used for data warehousing and large transactional databases. Examples include you can make use of these kinds of VM for Cassandra, MongoDB, and a Redis cache kind of stuff. Next one is VM for graphics and processing. They are very good for graphics related processing which provide high processing capabilities for data processing and rendering data in a graphical format. So these are the multiple types of VM that you can choose and use it. Some of them are custom built and many of them are all available in the marketplace where you can go and pick up, configure it, and then start using it. Now, let's see some of the top benefits of going for VMs. There are many benefits in the VM, and the top five are listed here. See, the first one is operate multiple instances of OS. Due to extract layer of abstraction, it is possible to mix and match operating system by running a Windows VM inside a Linux OS or a Linux VM on a Mac OS. The second benefit is multiple VMs on the same server hardware. This feature virtualization allows us to consolidate our computing resources, which allows us to reduce space and the maintenance cost. So that's one of the benefit of a virtual machine. And the third one is consolidation of apps and managing them using a single server. Since the VM supports for multiple OS, we can bring multiple apps together which require multiple OS, and so consolidation of our apps makes life easier. The fourth one, scale the VMs as and when required. That's the fourth one. You can spin a VM very quickly in the cloud environment. It is easy to create and manage multiple virtual machine images. And finally, restore the systems in the event of disasters. Since the VM images shall be copied easily, they can also be restored so quickly. This will help us to manage the disasters and we can achieve business continuity easily using VMs. Other than that, there are other benefits which include number one, cost savings. It saves cost to you since there is no need for server hardware procurement to bring up a VM to host an app in a new operating system. You can do it with existing hardware using hypervisor, create a new user, and then host your new app there. So it saves lots of cost. That's number one. Number two, easy provisioning. You can provision a VM quickly in a matter of minutes with the image that you already have it. That's the second advantage. And the third one is the increased productivity. You can create as many environment as you want, so that creation of quick environment for testing or for building POC are much easier, and that increases the productivity of the team. The fourth one is it's good for efficient DevOps. It's suitable for creation and testing of DevSecOps environment. You can really build such environment very quickly and then put your application it into a DevOps kind of setup. The fifth one is the environment friendly for IT operations. Since we are using a single large server for creating VMs and we are not purchasing a newer hardware, that ensures it's a kind of environment friendly. And next is full isolation, which means more security. Since it is isolated with the host OS, you can leverage the benefit of security and it ensures portability, which means the VMs can run old applications better using the operating system what that's supposed to be. And so better resource allocation is also another advantage of having virtual machines. So these are the combined benefits of having virtual machine in your environment. Now, let's see what are the issues that we have with the VMs. The first one is about the cost. The upfront cost for procuring the server hardware to configure multiple VMs is higher. The greater the scalability or availability that you expect, definitely a initial investment that is huge in terms of the amount that we spend for setting up or for procuring the server environment. Next one is the complexity. Setting up security, connectivity, and routing rules requires good amount of technical knowledge, and you need to have networking specialists all throughout in order to handle complex VM setup. The third one is related to binding to one location. If you have a large set of VMs configured on a single large server, that might lead to issues with respect to disaster situations. Though we make a copy of VM and replicate it elsewhere or use such images to handle disaster recovery, it's always a risk to have a single point of server failure at a location. So that's another issue with the VMs. And finally, it's quite difficult to keep track of the software and their versions inside the VMs. Okay, so these are the some of the issues with respect to the VMs. Next, let's see the big topic that is related to virtual machine scale set. We know elastic computing is a kind of it's an ability to quickly expand or decrease the computing processing memory and storage require resources to meet changing demands without worrying about the capacity planning and engineering for the peak usage. There may be requirement to increase the number of VMs based on demand and wherein scale set is rightly fitting. So virtual machine scale set is an interesting service offered by Microsoft Azure, which helps to create and manage a set of identical auto scaling of virtual machines. The number of VM instances can automatically increase or decrease based upon the scheduled conditions. When you configure a VM, you need to manually enable auto scaling. You need to enable the auto scaling feature in virtual machine scale set to get benefits of auto scaling. Couple of more things that you need to note here. When you have a VMs that run your application, it's important to maintain a consistent configuration across your environment. For reliable performance of your application, the VM size, disk configuration, and application installed should match with all the VMs. With this VM scale set, all VM instances are created from the same OS image and having the similar configuration. So this approach lets you easily manage hundreds of VM without extra configuration tasks in network environment. So these are the couple of things that you have to note it down under the heading of virtual machine scale set. Next, let's see why and where we need a VM scale set. Here, first we understand, in the previous slide, we understood that VM scale set are identical VMs to support elasticity principle. You can create thousands of identical copy of marketplace VMs or 600 copies of custom built VMs as a scale set. You need to remember this number: 1,000 identical copy of marketplace VM or 600 copies of custom built VMs as scale set. Let's look into this diagram. Here we have three tier architecture comprising of a front end, a business tier, and a business database tier. If there is a sudden increase in the number of requests that hits the web tier, it is important to scale the web tier to serve the incoming requests. Look, this is what going to happen. Okay, so your web tier will be auto scaled based upon the incoming requests. This is how the scaling is going to happen. So this virtual machines which host the web tier will be scaled up like this. Same thing will happen for the business tier as well as the database tier, so that you can you can make sure that the entire landscape is highly available irrespective of the demand. Next, let's see some common properties between the VMs and the VM scale set. And both are of type infrastructure as a service. That's number one point. Number two, the VMs allows only vertical scaling. Whereas if you set VM for auto scaling, the number of VMs of similar size and type grow or shrink based upon the demand. Third important thing, VMs provide capability over total control over OS and the software. That is at the gust level. And the fourth important stuff, it support custom images as well as the market images that we have seen in the previous slide. And the fifth one, VMs are best suited for the items listed out here. Okay, it's for building custom software, lift and shift scenarios. You need not worry about the operating systems because you can emulate the any operating system as part of PM image, and it's suitable for hosting web app or web service. You can host your database, desktop apps. It can act as a jump box or data gateways. So if you take VM scale set, you need to consider key important stuff. These remember these numbers: the 1,000 for custom build images and 600 for marketplace images. Though VMs are set for auto scaling while configuring, virtual machine scale set uses load balancers and ensures that auto scaling is available. So these are the stuffs related to virtual machine and the virtual machine scale set. And I hope this session is helpful to you for your learning, interview preparation, as well as any exam preparation. This is an introductory stuff related to virtual machine and virtual machine scale set. And this is not the end of the session. We are going to continue our learning process in the next session also. Till then, stay safe. Thank you and bye.